All right, everybody, let's do a few problems off of the 8.4 worksheet. I wasn't able to give you guys a CUDA worksheet for this section right here because they don't really have any problems that deal with angles of elevation and depression. So this is the worksheet from your textbook, which we really haven't been using at all. So it's called the Pearson worksheet. Okay, the first 8 problems deal with this, and I thought I'd go ahead and do 1 through 4 with you and then let you guys try 5 through 8 on your own. We got to have a diagram right here. We've got kind of a ship at sea right here, and then we've got this flock of seagulls or something up here that's in the air above, and then a submarine here that's located below. The important thing to remember is the water stays level here, so that's kind of your vantage point here. And we're supposed to describe each of the 4 angles here as it relates to a situation in the diagram. What they mean, guys, is they want for each one of those angles for us to say whether it's an angle of elevation or an angle of depression. So let's take a look at angle 1. Angle 1 is located right over here. And what we said in our notes on 8.4 that's important is that an angle of elevation or depression is always measured from a horizontal line. Now, the horizontal line here is coming from the bird's point of view looking over in this direction, kind of towards the west. And angle 1 is measuring how far down those birds would have to look in order to see the ship. So because this angle is below this horizontal line right here, angle 1 is an angle of depression. All right, let's move on to angle 2 now. Angle 2 is located right here. The horizontal line is kind of the perspective coming off of the deck of the ship looking out, and then angle 2 then is how far somebody on the ship would have to look up in order to see that same flock of birds up there. So since angle 2 is above this horizontal line, number 2 is an angle of elevation. Let's move on to number 3. Now I think the submarine below water comes into play. All right, the submarine is below the ship and off to the side. Angle 3 is located right here. And again, the horizontal line shoots out to the right here. Angle 3 is below that horizontal line. That's how many degrees down, below horizontal, somebody on the bow of the ship would have to look in order to see the submarine. So since angle 3 is below a horizontal line, that is an angle of depression. Angle 4, located right down here, is how far somebody on the submarine would have to look up in order to see the ship. Here's the horizontal line coming out of the submarine. Since angle 4 is above that horizontal line, angle 4 is an angle of elevation. Okay, so hopefully 5 through 8 make a little bit of sense for you now. Let's jump to problem number 9. We're supposed to find the value of x, and there really isn't a whole lot going on here that's different from what we did in 8.3. We have a right triangle. One side length is given to us. This 125-foot side is our hypotenuse, which we know right away because it's across from the right angle. Gotcha. And we were given one of the acute angles, which is 40 degrees. We're trying to come up with the measure of x. Okay, 125 is the hypotenuse, so x is one of the legs. We just have to determine if x is the opposite leg or the adjacent leg. Opposite, from this person's perspective right here, opposite would mean across from them. So this would be the opposite leg. That makes x the adjacent leg. All right, don't care about the opposite here. So hypotenuse and adjacent. Think about SOHCAHTOA. This is a cosine problem. So we write cosine. The angle measure, if we know it, always comes after that. So cosine of 40 degrees equals, and the definition of cosine is adjacent leg over hypotenuse. The adjacent leg is x. The hypotenuse is 125 feet. So that's our setup. That's our equation. And we just have to solve for x. Right now, x is being divided by 125, so we're going to multiply both sides by 125, and that should be everything we need. Those 125s cancel, and we're going to get x is equal to 125 cosine of 40. So let me go to my calculator here, and okay, here we go. 125 multiplied by the cosine of 40 degrees gets us 95.75 blah, blah, blah. What did the directions say to round right there? Round to the nearest tenth, it said. So that's going to be 95.8, everybody, for our answer here for that. 95.8. Since it's kind of a setup problem right there, I'm going to include units too, and that's going to be feet. And again, just one more thing to think about, the one side we were given in this triangle was our hypotenuse of 125 feet. So we know that each leg, in turn, has to be less than that 125. So that answer of 95.8 seems realistic to me. And let's do one more problem together. This one's a straight-up word problem, which I know people don't really like. This one is similar to a problem we did in our 8.4 notes, but it's got a little wrinkle in it. A person is standing 40 feet from a flagpole. So let's do this. Let's draw some level ground. We've got a person standing over here on the ground, and they are 40 feet away from the base of a flagpole. So this distance right down here is 40 feet. The flagpole obviously extends up into the air, kind of looking something like this. Okay, and that person looks up to see the top of the pole at a 35-degree angle of elevation. And this problem is a little bit more realistic than the one that I did with you before. Here's why. The person's eyes, obviously, are not on the ground itself. So what this problem does is it uses a horizontal line coming out of the person's eye level, and here's your right angle and there's your right triangle. Now the angle of elevation is how many degrees up this person needs to look from a horizontal line to see the top of the flagpole. So this person is looking up 35 degrees. So there's your angle of elevation. It says that the person's eye level is 4 feet from the ground. So this distance from here to here is 4 feet. Now that same distance is going to transfer over here onto the right side of this diagram. This distance from here to here is also going to be 4 feet. So what we've really drawn here is a right triangle with a small little rectangle underneath that it's resting on. Now the question here is, what is the height of the flagpole to the nearest foot? Now if you look just at the right triangle, we can use trigonometry to find this distance right here. I'm actually not going to call that h. I'm going to go ahead and call that x, and we're going to try to solve for that. Then, once we get done with that, we're going to come back and try to figure out the entire height of this flagpole off of the ground. And you might already see the relationship between x and h. All right. Let's see what we can do. This 40-foot measurement on the bottom is the same as this measurement on the bottom of the triangle, so here we go. From the 35-degree angle where our person here is standing, the 40 feet is the adjacent leg, and the x over here is the opposite leg. So with adjacent leg and opposite, this is a tangent problem. The tangent of 35 degrees is equal to opposite leg over adjacent leg is going to be x over 40. This is the best possible setup right here for a trig equation. The place we like the variable the most is in the top of the fraction. All we have to do now to get rid of that 40 that's being divided there, or they're dividing by, is we need to multiply both sides by 40. So, without a whole lot of work, we're going to come up with x pretty quickly here, guys. X is equal to, and we need 40 times the tangent of 35 degrees. So 40 tangent of 35 is going to get us an answer of 28, almost right on the nose right there, 28.00, technically 28.01. Come on now. Here we go. So they wanted everything to the nearest foot, they said. So that means no decimals. So x is going to be 28 feet. Now what that means, everybody, is that the top of the flagpole right here is 28 feet above this person's eye level. So we just found x right here to be 28 feet. But because this person's eye level right here was 4 feet above the ground, if we want to find our height, we've got to take the 28 feet that this thing extends above the person's eye level and add the 4 feet below it. So the actual height of this flagpole then is going to be 32 feet. And that is more complicated than the example we had done earlier, but it's also much more realistic because, as we said, a person's eyes are not down on the ground. The height of the person looking up at the flagpole might determine how big of an angle of elevation they need to see the top. Okay, I hope you guys noticed on the 8.4 homework, I only assigned problems 1 through 19, so hopefully you can finish up 14 through 19 at the end. Don't worry about anything that comes after problem number 19. All right, guys, good luck. Let me know if you have any more questions.